Hi, good morning, everyone. We are very excited to be here to present on this topic. I'm Kamini. I'm a product manager in Broadcom. I've been with the core switching group for about 8 years now. I have with me Rita, who's the principal software manager with Microsoft Azure network. And we'll start off with what the motivation is behind this Disag chassis, the need for this, and then we'll continue on to the technical challenges and how we are overcoming, and then end with what are the Broadcom chipsets that is meeting Microsoft's needs. Okay. At a high level, as most of you are probably already aware, the SONiC Disaggregated Chassis helps break down your traditional monolithic chassis into multiple physical boxes. You have the physical level disaggregation, plus you get the hardware and software abstractions level of disaggregation also. This gives much better flexibility in terms of how you design the network, how you change, and how you cable, and all of those. And also increase scalability by doing this abstracted way. And by having the clear hardware abstractions, we are no longer limited by the physical constraints of a single big chassis. And we are also seeing improved operational ease for configuration and management of these systems. And with all the OCP is all about being open and open ecosystem and all that. And this is a classic case of multi-vendor ecosystem, bringing in multiple partners, multiple OEM, ODM vendors, based on merchant silicon, and Ethernet is the technology to go, and with all the open SONiC stack. Over to you, Rita.
All right. So with SONiC and SI, we're able to achieve hardware and software disaggregation. We started the SONiC chassis journey by first enabling SONiC in multi-ASIC pizza box switch. We modeled each ASIC with instances of SONiC Dockers and SI, but connected via BGP. And then we extended this design to modular chassis system with fabric cards, supervisor cards, and line cards. The supervisor card or line cards often have also a number of ASICs, and so the supervisor card and line cards can leverage the multi-ASIC SONiC design that we had built. However, next slide. However, it is not fully disaggregated, especially in the hardware layer. In the modular chassis system, the supervisor module is a critical component in the system, controlling thermal, PDUs, fabric switches, and fabric links. And then in the hardware forwarding layer, the line cards, right, the ingress line cards, egress line cards, and the fabric links has very close relationship with each other to complete the whole data path. We want fully disaggregated system. And eventually, what we would like to build is only pizza box switches connecting to each other. Next. The new SONiC Disaggregated Chassis will be only pizza box, as I mentioned, and the T2 layer will be split into upper T2 and lower T2. So these 4 boxes here would assemble SONiC chassis. The upper T2 will be connected to routers outside of the data center, and therefore, typically, deep buffer ASICs will be needed. The lower T2 will be connecting to T1 devices, and therefore, high radix ASICs will be needed. But in this layer, no deep buffer ASICs will be needed. With the new SONiC Disaggregated Chassis, everything runs over IP and Ethernet between the pizza box switches. This makes operations and management much easier and much more standardized. We eliminated the need of dedicated fabric modules and management modules, which leads to great power savings and cost savings. This also reduces the risk of hardware failures. And because the design is modular, this gives us the flexibility to scale out or scale up as we need. Next. The UT2 and lower T2 boxes serve different roles in the data center. For the east-west traffic, it stays within the lower T2 layer. The lower T2 boxes would, when using high radix ASICs, you'll be able to connect more T1 devices than traditional chassis line cards. The north-south traffic will be between UT2 and lower T2. And as I mentioned earlier, the UT2 will be connected to what we call regional network gateways. Outside of the data center, it needs longer cables, debuffers, as well as encryption support. Now let us walk through a routing implication when there is a mix of traditional and new disaggregated T2 designs across data centers. In this example, on the top, we have the regional network gateway connecting to two data center fabrics. The DC one on the left side is the new disaggregated T2s. Here, the UT2 and LT2 are assigned separate ASNs. And then below them, it's T1 and T0 also have separate ASNs. The one on the right, it's DC2, follows the traditional design where the T2 is a single layer. Now, there are some services using Anycast VIP where the same IP prefix is advertised across data center so that traffic can be steered to the best endpoint. However, with the additional ASN assigned or introduced in the disaggregated T2, for traffic going to the Anycast VIP, now the ASN path will be longer compared to traditional data center. So this could potentially cause overutilization for DC2 and not a very optimal routing. To overcome the routing bias or the ECMP limitation, we propose to implement BGP confederation using SONiC. The upper T2 and the lower T2 are still assigned separate ASN, but you will be grouped under a confederation ASN. So this can make the UT2 and LT2 to present externally as a single AS so that we can still preserve the EBG relationship across all the tiers for the fine-grained control of the routing policies. So from the RNG point of view, now the DC1 and DC2 would appear equal, enabling ECMP for the Anycast VIP. Now, how are we deploying the new disaggregated T2s? We are not deploying them as logical chassis, but rather the UT2s and LT2s will be fully meshed, with the UT2 or LT2 each connected to each device in its adjacent layer. This enables high availability and multiple forwarding paths. So overall, this design has improved operational improvement and also improves the resiliency. We can also leverage many of our management tooling and experience for SONiC T0 and T1s in the T2 layers as well, because now they are all pizza box based. The new SONiC disaggregated design gives us a very clear path how we can scale our data center spine capacity over time. We start with two upper T2 switches with 1440 terabits Asics, connected to two lower T2 with the 512 terabits Asics. As I mentioned, this could ensemble for example, 400 gig chassis. As newer silicon becomes available, we could swap the two upper T2 switches with a single UT2 switch with 25.6 terabits ASIC. Eventually, link that with an even bigger lower T2 switch with 102 terabits capacity. Not yet. Yeah, so what's important is that the overall architecture does not change. Because of the modular design of this system, this gives us a flexibility that we could upgrade one layer at a time based on our needs. If we want more faster, or if we want more faster uplinks, we could upgrade just the upper layer T2 switches. And then if we want more fan-out, we can scale the lower T2 layer without touching the upper T2 and RNG connectivity. And with this flexibility, we could grow the capacity as we need, support more services and tenants, while keeping the operation simple and consistent. And that is the reason why we are adopting this new disaggregated design moving forward.
Thank you, Rita. So as Rita mentioned, the growth of capacity is one consistent thing that we keep seeing. And as we see in the slide, Broadcom has had 11 plus years of predictable execution. So we started with the Tomahawk line and grew to Tomahawk 2, Tomahawk 3, now on to Tomahawk 6 that is sampling since June. And this is the 102 tera that, that is for very future-proofed needs for Azure data center. And every time, this is all merchant silicon based, this is all Ethernet based, and each generation has, for its generation and across the industry, we have the highest radix and port density. And we are always the first to market at every generation, with highest network efficiency, highest SerDes, port SerDes speed, and the lowest power consumption per these pizza boxes, every generation. And if you see the graph itself shows that it's a very consistent execution across the board, and every 18 to 24 months, a new silicon gets released. And of course, with all of this, the growing needs and the capacity and all that, it's very important to have the efficient congestion management also built in. And we have all the PFC, ECN, all built in the hardware to take care of the growing needs. And talking about the upper T2 and all the connectivity to the regional hub that Rita mentioned about, this is where we need the deep buffered switches. And this is also merchant silicon based. This is a slightly different architecture. This is VOQ architecture based. And all of these have deep buffers. We have various portfolio. One is the centralized Qumran series, which is, could be positioned for the future UT2. And we also have the modular fabric element and the network line card with the Jericho and Ramon series that is used today in Azure T2. And the key thing here is, the other thing I want to talk about is the need for security. So as this pin extends out towards the regional hub gateway, the security becomes paramount important. And we do have MACsec and IPsec integrated in the silicon in J2C+ line. In fact, MACsec is at line rate on all the ports. And also, because we have a broad choice of silicon, the qualification effort is only an incremental delta. We don't have to requalify every time you change the boxes. It is just an incremental qualification, and it makes the upgrade much easier. Now, focusing on the specific security requirement, Microsoft and Broadcom, we have been actively collaborating over multiple years to have the whole SONiC stack ready, SDK, SI, SONiC layers. And currently, the SI specification for the MACsec and IPsec FIP compliance, which becomes important when you are looking to use this this network gets used in the federal certifications, those aspects, the FIPS compliance becomes very key. And so we have the SI specification ready. It is all merged in the upcoming version 1.17 SI headers. And this provides the SI API interaction and enhancements for triggering the POS, which is the pre-operational self-test, for the FIPS compliance. And here, one thing to note is the single SI MACsec object ID can serve one or more physical MACsec engines and port. And new attribute is also introduced to trigger the post at the SI MACsec engine ID level. And if you see, this is all like everything is open stack here. This is all SI SONiC, nothing proprietary, no proprietary technology. It's all Ethernet. And the SI implementation is also something that is available soon. This is almost at the end of the execution phase. And both Microsoft and Broadcom, we are also working closely with the OEM and ODM partner ecosystem to make sure that together we enable the Azure network and take it to production. Next is the call for action. So here, of course, we would love to invite contributions to the SI and SONiC community as always. And both in terms of SI specification, feature, or SONiC feature, or hardware platform contribution, there are so many ways that the community can contribute. And the SI spec is linked here, and the community meeting calendars are available. And These are all very insightful meetings where you learn a lot of things, how the industry is progressing, and a whole new things. Thank you so much for your time.
Thank you.
So good to see that we are going on a tower level. But is there still a space for a chassis, modular chassis? For example, one other thing when we had a modular chassis, it was said was like the space, like for example, the number of power cord which you require to put it on a plug, that'll be one. Like you can have every tower being a line card. Probably can put 7 or 8 line cards and have only one plug. And the power which is consumed per port was kind of less. That's one thing I've been here. When you go at tower level, like between upper tower and lower tower, now you have external optics, which wasn't there in the centralized chassis. So there are like still few advantages which have been told initially, like T2 modular chassis has. So still, is there a space for a modular T2 chassis, or like going forward, everything is going to be disaggregated upper and lower T2 towers only?
So your question is about space implications?
Space implication and the optics which you have to connect between the upper tower and lower tower.
Right, right. Yeah, very good question. So indeed, what I did not mention is, for example, now there will be much more cables connecting the upper T2s and the lower T2s exposed outside, right? And then in the modular chassis system, the fabric links, it's inside the chassis. Correct. So yeah, cables management, it's definitely a key thing that we got to manage. And then also, as we could see in this OCP, right, there's like continuous improvement in the optics, like there's LPOs, there's QSFP, 400 gig and 800 gig. So these will be actually major efforts that we'll be focusing as well. Yeah.
Okay, but you're saying there is no more modular chassis, it's always going to be upper tower going.
This is the new thing that we're working on right now. I think, they probably will still coexist. Yeah.
Okay, good. Thank you.
Any other questions for the speakers? All right, I see none. Thank you.
Thank you.